Good morning, all. My name is Rahul Kumar, and I am a PhD student at University of Tennessee at Chattanooga. And today we'll be discussing about Pthreads, and we'll be doing one exercise in which we will be determining prime numbers using a parallel algorithm, which will be implementing using Pthreads. So let's discuss about Pthreads first. Like Pthreads are one of the parallelism approaches that is available for a thread-based parallel or thread-based parallelization. And in this exercise, we will be generating 10 random prime numbers, and we will be using uh, mutex lock and barrier synchronization uh, preventing the race condition. What is race condition is that if you don't use any mutex lock or any of the synchronization techniques, then there will be no way for multiple threads to know uh, that they are writing to the main program at the same times. So to prevent such type of conditions in which multiple threads are trying to write a particular variable or print something, so we use barriers or mutex locks. So I will try to explain this part from the code itself. So let me pull that up. Eh, Yeah. So here we have the code. This has been implemented in C. So the library that is needed for this is pthread.h. And because uh, we are storing time and we are using math operations, libraries are also included. So in this, we are explicitly defining the number of threads as 100, and this can be changed. Let me change it to, let's say, 10 threads, and the maximum try that each individual thread will get to generate a prime number will be 10, and we are defining a maximum value, a very large value for this, so that it doesn't exceed this value. So before moving forward, we'll discuss briefly about barriers and how to initialize and destroy them, and how to create a, a weight condition, or yeah, mainly a weight condition. So for this, I'll be using some of the AI. So let's go through this one. So first of all, we are creating a barrier. So in a barrier, we are defining pthread mutex lock. So we are creating a barrier in which we are creating a lock, ensuring that only one thread updates the count. So a count means like we're calculating that how many times a prime number is generated. So whenever a thread generates a prime number, the count increases by one. And in this way, we make sure that we only generate 10 prime numbers. So then this is the condition. So condition able to put thread to sleep and wake up. So it's conditional. So if the condition is met, the threads will wake up. And this is the total number of threads that it is expecting, the total threads that require to be at barrier for it to proceed. And the count is the tracks how many number of threads are there at the barrier. So if all the threads are at barrier, so the barrier breaks, and or you can say the barrier unlocks. So so this is basically initializing the barrier. And after this, we are initializing the barrier. There will be individual functions for initializing, destroying, and for a barrier weight condition. These are the three conditions that are being used. So let me see, where are these? Okay, so here we have barrier, yeah. So this is initializing the barrier. So this setups the mutex lock. So we are initializing, so we are locking it and set up the condition variable. If the condition is met, then it unlocks and sets the expected number of threads. So yeah. So here we have a pointer P which updates the counter. So and a pointer, and it also updates the number of threads. Then barrier destroy. So a pointer for destroying the barriers, and then we have wait. So if one thread enters, so if let's assume that a thread enters the barrier, then the counter increases, so counter +1, and then if all the threads have arrived, the barrier wakes up, and then it basically unlocks, and you can proceed further in your code. So broadcast wakes all waiting threads, and everyone proceeds, or else it again places a wait condition. It creates a condition. Otherwise, if all the threads have not reached, it will create a condition to it will send a condition for locking or creating a lock. And for unlocking, mutex unlock. Yeah. So I think this will be better seen from the code. Yeah. So these are the barrier initialize. We are initializing the barriers. We are locking. We are putting a mutex lock. Then we are destroying, and then there is a wait condition. So if this goes, otherwise it will implement. It will unlock the barrier and proceed further. So other one we have is thread arguments, which basically includes the rank and barrier. Let's point out the barriers. I think this is also there, yeah. Pointer to the shared barrier among all threads. So what is happening over here is this is for initializing. So initially we are initializing to 0 found. Found will refer to number of prime numbers that have been found. And to test, this is the number that we'll be testing, and this will be getting updated. So here we are, the maximum tries here is now 10 tries, and we'll generate a random array with 64 bit over here, and then we'll test against the maximum value. And then we are calling a function is prime, which is defined here. Yeah, it's defined over here. So basically it checks if it is divisible by 2. If it is, then it is not a prime number. And if it is a prime number, if it is 2, otherwise it is not. And then it checks for 3, 5, and 7, and like all other uh, odd numbers, because 2 is the only even prime number. And it checks until the maximum values until which it checks is the square root of the number that has been used. Because even if it is a prime number, it will be divisible by its own root, square root. So that's why this maximum condition is there. So yes, so if it is found, then the found will go to 1 and the loop will break, and then the barrier will synchronize. So each thread, once they compute or they have surpasses this, they have found a prime number, or they have exceeded the number of tries, uh, they will have to wait until all the barriers are synchronized. And and after that, if it is found, if found, then it will print that they have found a prime number and they will print it, and otherwise they will print that there was did not find and did not report any prime number. So here we are creating the number of threads, pthread.t, initializing with a num threads. Then we are creating a barrier pointer as p. Then we are feeding the random number generator and we are initializing the barrier. That is a condition like all the 10 threads are at a particular point until that happens, none of the threads can proceed further. So over here, if even if the first threads found a prime number, it cannot proceed further unless the others do too. So this is one of the conditions. And then here in this one, yeah, over here we are creating multiple parallel operations. So in this, each thread is given the start function and an argument I. Uh, let's see what else. Yeah, I think this is it. And then we are collecting and returning, and we are joining all the threads and value. And then barrier destroy for destroying the point. So this was the code. Let's save it because initially it was 100 threads and this was the run with 100 threads. So to compile this, similar to OpenMP, we use GCC with a flag for pthread. And here uh, negative LM is dash LM is for the math operation that is we are using square root. So this is compiled, and if we run this program, yeah, so see how many it is generated? 6, 1, 2, 3, 4. It has generated four primes. Uh, yeah. So you can see that it waits until all the threads are synchronized, like they have either found a prime number or they have reached the maximum number of tries, and after that it prints everything. So let's change the code a little bit. Let's go with 20 when prime. What is happening? Prime e thread. Let me see. I think I made an error. Yeah, so here we are not setting up the number of primes that we want. We are just specifying the number of times a thread can try. So maybe we can have primes equal to number of threads or maybe less. It depends on whether it found a prime or not. Let's give it I think 30 and we'll end it with this. Let's see. Yeah, so yes, so it doesn't restrict on the number of primes that are generated, but it restricts the number of tries it does. So right now we have 1, 2, 3, 4, 5, 6, 7, 8, 8 primes with 30 hits. So let me just increase the number of tries to 100, maybe 50. Let's see whether this. I think it should increase the number of primes that we found. So let's hope that it works. Yeah. So you can see that increasing the number of tries 1, 2, 3, 4, 5, 6, 7, 8, 9. So apparently more than this. Yeah. So in this one, the basic aim was to show like how you can implement mutex lock and synchronization and how it works in case of a prime number generator. So I hope you guys have learned something new. Thank you for watching this video and have a good day.